What is this abomination? Okay, I'm a high school teacher. A lot of times I teach geometry, and my students love to give me memes that make me mad or think I'll not be able to explain them. So anyway, we've got this lovely triangle here. Take a look at it. Yeah, it's an abomination. Okay, so we have the hypotenuse here, and it's 0. Well, that shouldn't be possible, but we do have a side length there of 1, and then the other side length is I. Now, let's assume that you have absolutely no idea what's going on here. Well, I here is clearly the imaginary number. I'm going to dilate myself down so I have a little bit of whiteboard space above me. And let's remind you a few things about imaginary numbers in case you have no idea. I try to make sure my content here is accessible to anybody who's taken high school math, but you may or may not remember imaginary numbers. So basically, I is the square root of -1, which means that I squared is -1. And so understanding this meme relies on this fact. You're also required to remember the Pythagorean theorem, which you may have forgotten that's what it's called, but you probably remember the good old a squared plus b squared equals c squared. My students love this formula. They can remember a squared plus b squared equals c squared. They can't usually apply it correctly, but hey, they remember those letters. Now, what does this mean? It means that in any right triangle, the sum of the squares of the legs, that's the two sides that together make the 90-degree angle, equals the square of the hypotenuse. Neat. So in this problem, a and b are the 1 and the I, and the 0 is the hypotenuse. Well, let's see what we get. If we plug in a 1 for a, 1 squared, plus b will be our I squared, and then that will equal c squared. And let's see if the hypotenuse comes out as 0, and it should now be obvious that that's the case. 1 squared is 1 times 1, which is 1, plus I squared, and as we defined over here, I squared should be -1. Cool, and 1 plus -1 is 0, leaving us with c squared equals 0. Undo a square with its inverse operation, square rooting, and the square root of 0 is 0, since 0 times 0 is 0. Hey, this all checks out. It appears to be completely valid. Okay, so in some ways, you could just leave it at that. Like, all right, neat. It's a cool right triangle that seems impossible, but, fine. If we want to think about this a little bit more, about what's going on here, though, so why does this seem impossible? Well, we shouldn't be able to have a side length there that's 0. But the real issue here is that this type of thing doesn't make sense because you're using I in a context where it doesn't make sense. The Pythagorean theorem is something that's proved using Euclidean geometry in normal, real space. And imaginary numbers, which lead you to complex numbers, have a place, they have a purpose, they have some uses. And you do need to just keep in mind that they aren't exactly the same thing as are just normal real numbers. So without getting lost in the weeds here, because like I said, I want my channel to be approachable to anybody who's taken some amount of high school math, let's just say that thinking of I as a distance is a weird and complicated idea. And when we're thinking of the Pythagorean theorem, we're, thinking of actual normal space. And let's actually break this out into how do you prove the Pythagorean theorem? Well, what it's really talking about is building out squares. So when you're saying I squared in the Pythagorean theorem, and the a squared plus b squared equals c squared, you're actually talking about building out a square, right? If we actually think about this right triangle a little bit harder, what the Pythagorean theorem's really saying is that when you build out squares off the edges of this triangle, that the sum of the areas of these two smaller squares can fill perfectly into that third square. That's what the Pythagorean theorem is really saying. So when we're saying that the side length here is I, then we get a square that has side lengths of I, and when we multiply those together, we are getting an area that is -1. right? The area of that square is -1. So this diagram doesn't make sense unless you're careful to define the world that you're living in. If you're living in a world where negative areas don't make sense, then you're living in a world where imaginary numbers for your side lengths don't make sense. Okay? And that's why this seems so unintuitive. It's because it is, right? You're throwing together a really cool looking formula. I love this image. I think it's fun. It reminds me a little bit of the famous e to the I pi equals -1 kind of an idea. Which is one of my favorite formulas in math. This reminds me a bit of that, but to a level that's more approachable to somebody who's made it maybe through Algebra 2. So you've seen the Pythagorean theorem and you've seen a little bit of imaginary numbers. It's cool, but again, when we're using math to apply to real life, we have to make sure that we're using it in a way that makes sense. Math is consistent and it makes sense, but you're taking a pure logical system, and if you're applying it to the real world, you have to be careful to apply it in a way that actually makes sense to the situation you're talking about. So if we're expecting this triangle to represent a normal triangle in the normal reality that we live in, then we shouldn't be throwing imaginary numbers on there as a side length, because that produces things like negative area, which isn't a thing that makes a lot of sense in a lot of applications that we're used to. So anyway, if you enjoyed this video, you could consider subscribing to the channel if you're interested in other interesting math-related stuff that is accessible or helpful to anybody with a high school level of mathematical knowledge. And I hope that you have an excellent day.